In this tutorial we're going to use the Vivado 2017.2 software to download a simple design onto the Basys tree development board. The first thing we're going to do is select Create Project, Next, and then browse to the project location where we want to save it. So I'm going to save it to a demo folder I created on my desktop. You then give the project a name. So again, I'll call it Demo. RTL project is the project type that's selected by default, and that's what we want to use, so we just select Next. You then have to make sure that your target language and your simulator language are selected as VHDL. Then select Create File. So this is where we're going to create our gate file that will be downloaded onto the board. Click Next. Then you add any constraints, and this is optional. We're going to create a constraints file where we can assign input-output pins to our design to pins on the FPGA. So we'll call it pinout. Select OK. Then click Next. Then select the Basys tree development board, which is under Boards. Next, and then select Finish. It then asks us to assign input-output pins to our gate file which we've created. So A and B will be our inputs, and X will be our output. Then double click on our gate VHDL file, and we're going to say that X is equal to A and B. I'm going to purposely put an error on line 36 by getting rid of a semicolon. I'm going to do this because when we get to the compile stage, I'm going to show you where you can find any errors in your code. Next we click on the constraints file, and we assign pin numbers to our inputs and outputs. So you first have to type out set underscore property, then you type out package underscore pin. The first input we're going to assign to a pin is our A input, and that's going to go to switch 0, which is pin V17. Then we type out get underscore ports, and it's input A. You do the same for input A and output X. Copy and paste that. So input B is going to go to switch 1, which is V16, and output X is going to go to LED 0, which is U16. The number of the pins that the switches and LEDs are connected to are written on the development board. We now need to assign an input-output standard to each of these pins. So we'll copy that again, and instead of saying package underscore pin, we write IO standard, then L V C M. So this is the input output standard that we're going to use for all 3 pins. So we then save our constraints file. Now we're going to go to add sources, and we're going to add a simulation file. Through here we can also add any new constraint files we want, or any new design files, but we're going to add a simulation source. Click Next, create file, we're going to call it test bench. OK, and finish. Now our test bench won't have any input output pins because it'll be just used to create input stimulus and then check for the feedback of our device under test, which is our AND gate. So under simulation sources, we double click on our test bench, and the first thing we do is assign any signals we're going to use, which will be the inputs and outputs of our AND gate. And they'll be standard logic. We're then going to create a process where we assign input values to A and B. So we'll start off with 0, 0. And then check. First we put in a delay, so wait for 1 nanosecond. We've just picked 1 nanosecond, but it can be any amount of time. Then we check if x equals 0, which it should be if our inputs are 0, 0. Then report pass for inputs 0, 0. Else we're going to report that it failed. Then end if. So we'll copy and paste this 4 times for our 4 different tests. And then we'll just modify them. So the second test will be 0, 1. Third test will be 1, 0. And the fourth test will be 1, 1. Then we'll print out a report that our test bench is complete. These messages will be printed out to the TCL console, which I'll show you later. Then you type in wait and end process. The final step is to connect our test bench up to our DUT, which is our AND gate. And that's our test bench complete. Now when we press run simulation, it will compile the gate code and the test bench, and we should find the error that we put on line 36. Actually, first we need to go into simulation settings and edit the simulation time. So we're doing 1 nanosecond simulation, so we'll pick our simulation time of 4 nanoseconds. Press OK. Then run simulation. So it says there's an error. So to find where the error is, we go to the TCL console, and you can see it's saying there's an error here on line 38 of our gate file. Sorry, on line 37. So if we go to line 37, we can see the semicolon that we left out on line 36 is our problem. So we'll keep running this simulation and checking our TCL console until we found all the errors. So that's the only error in our code. So when we go to our simulation, we click on zoom to fit, and you can see the entire duration of our simulation, and you can see it works correctly with the output being 0 and then going high when both our inputs are high. If you go to TCL console, you can see all the messages that we asked to print out have been printed out. So pass for input 00, 01, 10 and 11, and test bench complete. So now that we have simulated our AND gate and we know that it's working correctly, our next step is to generate a bit stream that we can download onto the board. So we click on generate bit stream, click OK. And you can see up in the top right corner that the Vivado software is running, and it'll tell us when the bit stream has been generation has been complete. Okay, so after waiting for a minute or two, our bit stream generation has successfully completed. So I'll just close this box, and then I'll click on Open Hardware Manager. So making sure that your Basys 3 development board is connected into the USB port and turned on, you go to Open Target and Auto Connect, and it should find your Basys 3 development board. So the last step is to program device. So just click on Program Device, click on your target, and then it'll automatically detect the bitstream file that you've generated, and you press Program. And now I can see that my Basys 3 development board has been programmed successfully, and I'm just checking the two switches and everything's working fine. So that's the end of this tutorial.